Hi, and thanks for watching. Today we're going to do the derivation of the product rule for derivatives. So the goal of this video is to derive the product rule for finding derivatives from the limit definition of derivative. So if you think about what the product rule is, which we've done in class, if you want to take the derivative of a function written in terms of two functions of x. So u is a function in terms of x and v is a function in terms of x. Your derivative is going to be the first times the derivative of the second plus the second times the derivative of the first. Now, if our function, if f of x is two functions written in terms of u of x times v of x, then you can rewrite this derivative using your function notation. In other words, now we can actually replace the x's with something. This is a little bit more helpful. So we can rewrite this derivative in terms of our function notation. So f prime of x is going to be the same as f prime of u of x times v of x, which is going to end up being, so now f prime of x is going to be the first times the derivative of the second plus the second times the derivative of the first. So these two things really mean the same thing. It's just that one is written using the function notation and the other, we've just got the u and the v. We talk about this one more, but for this derivation, we're going to have to use this definition. Okay? All right, so let's think about where in the heck does this thing come from anyway? Well, when you're finding derivatives, we always start out with that limit definition of derivative. So hopefully you remember the limit definition of derivative. If you don't, I'll write it down for you. So this is the limit definition of derivative. Remember, it's a slope. If you look at the numerator, what we have here is a y sub 2 minus a y sub 1. And in the denominator, what we have here is an x sub 2 minus x sub 1. So if you always remember it as a slope, that really helps simplify where everything comes from. Now, in general, the denominator, we don't usually write it like that, since x minus x just leaves us with the h. Usually what you see in the denominator is just the h. So what we need to do now is apply this limit definition of derivative to our function that's written in terms of u and v. All right, so let's try doing this. If we do this, what we're going to end up with is f prime of x, which is written in terms of u of x times v of x. What we're going to have to do is we're going to have to figure out, first of all, what is our f of x plus h? All right, so f of x plus h, if everything's written in terms of u of v, u times v is going to be u of x plus h times v of x plus h. And f of x is just plain old f of x, which is u of x times v of x. All right, so now let's use this and the limit definition of derivative to substitute things in. All right, so what we need to do here is we need the numerator. We need f of x plus h, which is this piece here. Okay, so let's write that down. And then what we need to do is we need to subtract our f of x, which is right here. So we're going to subtract our u of x times our v of x. And then what we need to do is we need to divide everything by h. And darn it, I always forget. I should have written here the limit as h approaches 0, right? Because that is the essential component of this limit definition. All right, so let's look at what we've got here and see what's going on and see if we need to do anything to help us out. Let's apply the limit first of all. If h goes to 0, this is going to end up being u of x, because h is going to turn into 0, times v of x, because h is going to turn into 0, minus u of x times v of x, all over h, which gives us 0 over 0, and that's really bad. We've talked about that. We cannot have 0 over 0. That's the indeterminate form, so that's not going to work. So we need to monkey with this and see if there's anything that we can do to make it a little bit better. Now, there's a little trick that we're going to use, and it's not something that you would normally know unless you've done a lot of proofs. So let me show you what we're going to do. We are going to add u of x plus h times v of x, and also subtract that same thing, u of x plus h times v of x, to the numerator. When you add something and then subtract the exact same thing, you're going to end up with 0. So essentially, we're going to add and subtract 0 from the numerator, and that's going to help us solve this problem. So let me show you how that works. All right, so I've rewritten my derivative. Oh, and I have to put in this limit definition. Do any of you guys forget that? That drives me crazy. When we're in class, you're going to have to make sure I don't forget to do that. All right, so here you can see that I have my minus u of x plus h times v of x right here. I've subtracted that part there. So, and then I've also added this part here. And then you can tell all the stuff in black is my original definition from up above. Okay, so why does this help? In fact, this just kind of makes everything look really horrible, you're thinking. Well, kind of, but there's a nice little thing that happens here. So if you look at the first two terms, we're going to do some grouping and we're going to do some factoring. If we group these two terms together, what you see that factors out is a u of x plus h. So what we're going to do is we're going to factor that out. So let's go ahead and factor that out. All right, I've factored out the u of x plus h from the first two terms. Now let's look at the last two terms. From the last two terms, and we have to be careful here because there's a negative sign. So what I'm going to do is I'm going to add the opposite before I group these guys so that I don't get my signs wrong. Both of them have a v of x. We're going to factor out the v of x, and then we'll rearrange these two so that we have u of x plus h coming first since it's positive, and then minus the u of x. So if we factor that out, the v of x comes out, and we have to be careful because this is going to be a positive. We've changed that to a positive, so we have to make sure our factorization is correct. We're going to put this part first, u of x plus h, and we're going to put the minus u of x second. And if you notice, everything is all over h. Well, we can distribute division, so I'm going to rewrite this over h and rewrite this over h, so we have two separate fractions, and again we have the limit as h approaches 0. The reason I distributed the division is because now if you look at just this part, something interesting has happened. Go back to the limit definition of derivative, and I'll write it down here again for us just in case you've forgotten. Okay, here's the limit definition of derivative. If you look at what we've got here and what we've got here, they both look a lot like the limit definition of derivative. Just instead of f, you have v, and instead of f, you have u. So what this is equal to v prime of x, and this is equal to u prime of x if we apply this limit separately. So we need to apply the limit to this part and to this part. And according to the laws of limits, that is completely legal to do. But you have to remember that when you go back to your original problem, we have not applied the limit as h approaches 0 to this or to this. So we still need to apply the limit as h goes to 0 to our u of x plus h. We've already applied it to this part we've highlighted because that fits our definition of derivative. That would give us the derivative of v. So that's going to be taking the limit there, times v prime of x, plus, we haven't applied the limit to this yet, so we need to apply the limit as h goes to 0 of v of x. We have not yet done that. However, we did apply the limit to this part highlighted here because that fits the definition, and that gets us our u prime of x. All right, now if we simplify what we've got here, if we apply the limit and let h goes to 0, you end up with u of x times v prime of x plus, and since there's no h here, this doesn't change, it's just v of x times u prime of x. So If we look at what we've got here and think back to what this means, this is our derivative of x, given that the function, given f of x, is a function of the product of two other functions that can be written in terms of x, u of x times v of x. So we're done. Look at this. Ta-da! We have the first times the derivative of the second plus the second times the derivative of the first. So if this is a little bit confusing, that's okay. I don't expect you to have it memorized, but it is really cool to know. If you want to go back and rewatch it, I would encourage that. And you know what? Something you should really know about me is that I never, ever chew gum. Might come in handy sometime. You never know.